Welcome back to Create Stuff with Jim. I'm Jim. It's time to create something. On this episode, we're going to be creating something using this, a 3D printer. A lot of you may not know on how affordable and accessible this stuff is. But we're going to go over a lot of this in this episode. Now, to start things off, you may ask yourself, what are the limitations of what can I build with a 3D printer? Well, in all honesty, the sky's the limit. You only have, I'll count, you only have 3 limitations that is going to limit what you can build. Number 1 is the size of the machine. They make all different sizes, but whatever size of machine you have, that's going to limit on how big you can build. How strong the plastic is that there's several grades of plastic, and how strong the plastic, and depending on what you want to do with it, is going to be another limiting factor. And the final one is your own imagination. Is the sky is the limit. Whatever you can think of, like I say, you can generally turn into reality with a 3D printer. And I'm gonna be honest with you, I actually stumbled into this. When I got my plasma table, and I was waiting for it to, or I ordered it and I was waiting for it to come in, and I was learning how to use CAD, and I was like, well, what else can I use it for? And I was watching a tutorial on somebody else's YouTube channel on how to use the plasma table. And he made one small mention about a 3D printer and something he printed with it, and his only comment was, if you're going to be fabricating anything or building anything, you got to have a 3D printer. And that is so true. I have found that these are amazing tools to have, and you can build some incredible stuff. So now that we got now on to the next thing, I want to show you a few things that I've actually built with a 3D printer. I can't show you them all because I've built quite a few, and I'm going to build a lot more. So we'll start off with simple things. Well, simple but not simple is basically I have battery powered tools that most people use, and basically I made brackets where I can store the battery pack and the tools mounted to the wall. So that was actually, those are pretty neat. You can mock up parts. This is a 3D, I was mocking up to see if a part would fit. So you can do 3D mock-up parts. That turned out pretty well. Unfortunately, I'm not using that design anymore. More mock-ups. Like I said, anything you're trying out, which once again, these are designs that I'm not using anymore. But the neat thing is, before I could actually send these designs out to be laser cut, but before that I can 3D print them and test fit, make sure bolt holes line up, and make sure the bracket works before I spend the money and the time to send them out to get laser cut. And another really neat one is I can make switch plates. These are actually pretty neat. This one I made for Big Red. I still haven't put it in, but it sure does look neat. You can do raised lettering and do lettering in different colors. And that's actually another thing I'll tell you. Even with this 3D printer I have right here, I actually printed this using my other machine. I have 2. They are basically, this is a small one, I have a larger one. I had to print this one on my larger one. But you don't need a special dual extruder or dual filament machine to do 2 colors. And if you guys would like to see how to do this after you watch this video, if you have more questions and you want to see on how to print one of these switch plates with 2 different colors with raised lettering in a different color, leave me a note in the comments. If I get a couple people asking me to do that, I'll do another video to show you how this is done. This is really neat. So, but once again, really neat to make switch plates. So, and once again, and then another one, I was actually pushing my limits to see exactly what I can print, and I downloaded a free files to 3D print a remote control airplane. I never did finish it, but I really wanted to challenge myself on the complexity of the prints So this is actually pretty neat. And of course I didn't print it in one piece. I had to print it in multiple pieces and glue them together. But this is just a real testament on how versatile these machines are and what they can do. When I say your imagination is your limit, I mean, it truly is. it truly is. You can really do a lot of neat stuff with this stuff. But that was, maybe I'll finish that one day. So now, then we're moving to the final part. Is I know you guys, hopefully you guys are amazed and impressed with everything that you can do with this. And now, unfortunately, this is something that comes in everybody's minds these days, is the cost. Most of the time, technology, everything is incredibly expensive. My plasma table, which you've seen in other videos, is downright amazing and is actually one of the most affordable plasma tables you can get, and it was still a lot of money. Worth every penny though, but still a lot of money. But for this one, and actually this 3D printer right here is a replacement, is because I've had another one identical to it, same manufacturer, more or less the same one. I've been using it for over a year and a half. I can't tell you how many pieces I have printed with that printer. I mean, I broke that printer probably about 3 or 4 times, and I burned the heating element out in the tip. So I finally just broke down and bought a replacement. I originally bought my original one, I bought a year and a half ago for $200. You heard me right, $200. And this one is identical. Guess what? I paid 150 bucks for this. So they can actually be relatively affordable. They do get expensive with different features that you get and different sizes that you get. But I'll probably touch on later on in the video. I'm going to touch in later on in the video. I'm going to touch on certain features that I really have come to appreciate and I really like. So, but the one thing is, I really like the affordability. So, and then along with the affordability, I'm going to point out another thing is because it prints using plastic filament. This is just a cheap PLA plastic filament. This is really the bottom of the line filament you can use. You can use ABS plastic, you can have carbon fiber impregnated filament, all kinds. This is just a cheaper PLA plastic, and one of these spools, this is about 75% used. When this spool is full, it costs 20 bucks. And when I print a lot, this one spool will last 3 or 4 months, if not longer. It depends on how much you use it, but it's really really incredible. So the truth of it is, like this bracket right here for holding a DeWalt 20-volt battery pack, I think I might have less than $1 in plastic, if that, maybe 50 cents. Like I said, you can print these parts for very little money, and I have been thoroughly impressed. So I can't say enough more about it. So the machines are affordable, the filament's cheap, and then guess what? Designing the parts, the CAD I'm using is free. So to me, it doesn't get much better than that. So before we get into the project, I want to explain to you what we're going to do in this video today. Yes, we're making something, but I'm doing something more than just making it, because I've already told you the benefits of using a 3D printer. And what I'm going to do is I'm going to take you through the entire process, step by step, on how we do this. So I'm going to start with my idea. I have an idea. I've already proven it works, but now I just have to make it into reality, and so it's more usable. So we're going to take an idea, we're going to design it on CAD, we're going to produce a 3D model in CAD, and then after we produce a 3D model, we're going to take that model and we're going to convert it into a G-code that the 3D printer can understand. And then after we create that G-code, I'm going to show you how to take that G-code from the computer, put it into the machine, and getting it started. Then I'm going to do a time lapse. I'm going to show you the actual printing process of this, and then we're going to have the final product at the end. Then we're going to test it. So I'm going to show you step by step how to do it, and I've been looking forward to doing this just because when I figured this out, I'm sure there's videos out there that show it, but it would have been a little easier if I could have found one, and I couldn't find one. So I just want to put yet another one out there, just because I just really want to show that this is not difficult, this is not unaffordable, this is a very learnable item that you can do, or sorry, this is a very learnable skill that you can do, and there's nothing magical about it. It's not even expensive. You have a $150 machine with a $20 roll of filament. I mean, this is very affordable. So anyways, let me just quit my yakking, because I'm talking too much. I get very passionate about this, and like I said, I really stumbled into this by accident. So, and it has just been an amazing tool. So without any more yakking, let's get into it and let's go create something. All right, here we go. This is my idea. Well, if you watch the intro to this video and my others, you're going to notice that I use my CNC plasma cutter to actually use a Sharpie and draw on a piece of poster board. Now, this is how I did it. To get the Sharpie in there, all I did was wrap it with a lot of electrical tape to be able to hold the marker. So now it worked. There's no denying that. But the biggest thing I was doing was verifying that the idea worked. That this is definitely not the best way to do it. It's not the final way to do it. But I just want to verify that, number one, I could hold a Sharpie. I could write a G code that would that I could actually draw on a piece of paper or anything else. So because even though I made a pretty cool intro with it, I do have some other uses that, if you follow this channel, you'll probably see at one time or another. So once again, that's the idea. So now I want to 3D print a part to hold the Sharpie. So we're going to set that aside. So this is a Sharpie without tape on it. So I want to be able to make a piece that goes on this section of the Sharpie that I can clamp in place of my plasma torch on my plasma cutter. So that's very doable, and is what we can do. So to start off with it, I'm going to show you a few other parts that I've 3D printed. This is just a simple pointer. I actually clamped this into my plasma cutter, so I can use the point to line up a workpiece. So that's the purpose of this piece right here. I mean, I drew this up on CAD and I 3D printed it, and it works very well. So what we're going to end up doing is we're going to take this similar design. I'm going to take measurements off of this, and what we're going to do is we're going to stop this part right when it starts to taper down to a point. So it's only going to be about that long, and then we're going to put a hole in it, so the Sharpie can actually go through the center and the tip will come out the end. So that's more or less what we're planning on making. I'm going to take measurements off of this because I know this fits in the holder for my plasma torch on my table. So this should work very well. And then here's another one that I made. This is once again, I use this for the same purpose of aligning workpieces up on the plasma table. So, and basically all this is just a small flashlight, and what I can do is when I turn the light on, the tip lights up. It's a little hard to tell, but there's actually a hole in the middle of this. So the hole lets light through, so I can put this in, and rather than having to line up this tip on the workpiece, I can shine a dot on the workpiece so I can center it up, or I can run a test pattern just so I can see exactly where it's going to cut. So I know if I'm too close to an edge or another part, I can do that before I actually light the torch up, run the program, and screw it up and waste a piece of metal. So like I said, these were two two items that I printed out on my 3D printer already. So, and then also, anyways, that's what we're gonna do. So we're gonna jump on the computer, get onto CAD, and we're gonna get it started. All right, now that we're on the computer, let's get this party started. So we're gonna start. We're gonna open up Fusion 360, which I already had it open, and if you've never used Fusion 360 before, I do have a video posted where I gave a very brief introductory tutorial on how to use Fusion 360. So if you've never used it, I highly recommend you go check that video out, and it'll help you a lot in this. But getting right into it, we're going to start a new sketch. We're going to choose the XY plane just because that's where we want it to print on. So, and we're going to start off by doing the circle for where the Sharpie goes into. I've already done all the measuring. I wasn't going to bore you with all that this go around. So, but anyways, the hole for the Sharpie is going to be 0.42. That's not right. 0.42 inches. That is going to be the hole for the Sharpie. Now, the next diameter we're going to need, and this is for the lower part of the shoulder, and this may seem confusing, but when we go to build the model, this will make a lot of sense. So now we're going to select another circle. We're going to take the same center point, and this is going to be 1 inch. So we're going to go 1 inch, and then the final diameter that we're going to use is going to be 1.15. All right, those are all the diameters that we're looking for, and I think I'll go ahead and turn off the dimensions so it doesn't look as confusing. Let me zoom in here a little bit. So here's our center hole that's our center hole where the Sharpie goes through, and then this is going to be 1 diameter, and then there's going to be a step so it can keep it square in the holder for the plasma table, and then that's going to be outside the diameter. So now we're finished with this sketch. So we're going to click up here to finish sketch. We do that. We're going to go back to home. We're going to press home. So we see in this dimension. So now we're going to go up here. You have this extrude key, but I'm going to use hotkey E, which is basically the E key on the keyboard. So we're going to go into extrude mode, and we're going to pick to new component, and we're going to pick that section right there. And this is going to be the full height of what we're doing. So you can, to either extrude this, you can grab this arrow, you can move it up, down, whichever you want to do, but we're going up, and that dimension is going to be 0.85 inches. That's the maximum height of it. So we just drew a cylinder with a hole in the middle right now. So that's where the Sharpie is going to go through that hole. Now this is a feature that Fusion does whenever you create the first extrusion you do is if you come over here into sketches, it hits the little eyeball right there and it turns the sketch off on you the first time you do it. So now we got to turn that back on. So now we're going to make the outer body of this, so we have our little our ledge that can get squared up into the plasma table. So right now we're going to go hotkey E, we're going to do extrude again, and now we're going to hit this. Now I'm going to go ahead and move this up a little bit. Instead of doing a new body or component, it says join, because it's going to join this into the one we made earlier. So they're actually going to be considered one piece of the same component. There's a lot of tricks you can do with this depending on what you're doing, but we're making one piece, so we're just going to join it so it all makes the same. Now the height, that's going to be a ½ inch, 0.5 inches. Enter, and boom, there we go. Now I'm going to turn my sketch off so it doesn't look confusing, and that is about what we're looking for. That's pretty simple. This section right up here is going to clamp in to the clamp for the plasma torch, and then this shoulder,
this face right here is going to square it up on the holder. It should actually work pretty well. So that's basically what we're looking for, but there's still a few changes that I want to do. Is I'm going to leave this a nice sharp edge, just because it's right against where we want it square, so we're going to leave that. The sharp edge up there, I'm going to leave that too, just no big reason. But this edge right here, I want to round that off a little bit. So basically we're going to go up here on, if you remember from our tutorial on how to do a sketch, you had a fillet function. Well, in the 3D modeling aspect of it, you do have the fillet as well. You're going to click that, and basically you can see how I'm going to highlight that little edge right there. Then when I click it, then I have my arrow, and I'm actually going to readjust the model just so I can see that arrow, and I'm going to take it, and what you can do is I'm going to run it in, run it out, and you just really set this to something that looks appealing to you. We could go all the way like that, but I'm not going to do that. I need something for the clamp to hold on to. So we're just going to do 1/10 of an inch. Just, I mean, that'll round it off, make it look nice, and we still have something to clamp onto. So then you click OK, and we're there. So that's looking pretty good. Now, but there is another feature that I want to add to this, is because when we print it and I put the Sharpie in there, the Sharpie is going to be going from, this is actually upside down, it'll be going from the top, and I want to be able to clamp down on the Sharpie without, so when it puts it down, it doesn't push the Sharpie out, so it keeps a little bit of pressure on the whatever I'm drawing on. So what I want to do is I want to put a slit. So we'll go to the top view right here, is I want to put a slit right here so it's not a continuous circle. So when I clamp it down in the clamp for the plasma torch, that it'll actually compress this piece and clamp it down tight on the Sharpie. So in order to make this so it'll move, I need to put a little gap in there, and we're going to put about a 1/16 of an inch gap. So now how we're going to do this, and this will give me an opportunity to show you once again on how creating a sketch and 3D modeling all works together. So we're going to come up here and we're going to say we're going to create a sketch. We're creating a new sketch. Now you see down here, you see that if you remember when I started the original one, when I chose the XY plane, those are right here in the middle. So if I go to home, there are my 3 planes that I can select those 3 and start it on that particular plane. But I'm going to do this a little different. So because if you see how I highlight this section right here, I'm going to select that plane on top of the model of where I'm going to put my sketch. So that telemarketer, don't mind that. So so yeah, all right, back to where so when I highlight this, I'll put the sketch. So that sketch is going to be on the XY plane, but it is going to be 0.85 inches above the XY plane. So it's going to be Z plus 0.85. And I should have said this from the beginning, is you really have to help if your mind can grasp working on something in 3-dimensional, will help immensely. But I'm going to show you on how, like I said, on how the offset of this sketch is on an offset plane from the original one. All right, so I'm going to left click on that. So I created my new sketch. So now I'm going to put a 1/16 of an inch gap here, and there's many ways you can do this. This is just the way I'm doing it. And I'm going to turn the original sketch on so I can generally center off that centerpiece. I'm going to draw a rectangle. I'm going to start here. I'm going to start in the center. I'm going to draw out past the edge of the workpiece. So that's going to be like, we're going to do that 0.6 inches. That takes us out and beyond. I'm going to hit the tab key. Now we're going to come to the width. And the width is going to be 0.031. And that's going to be half of a 1/16 of an inch. So that's one. Now I'm going to draw another rectangle. And as I said, there's many ways to do this. This is just the way I like to do it. So So we come out here, and I'm going to touch that on the square, then I'm going to come up and it's going to keep the projected geometry, so they're both going to be 0.6 inches long. And now I have highlighted, and it's going to be 0.031 again. So now I have the total width of a 16th of an inch. So now I need to clean this up a little bit. So I'm going to come up here to the trim feature, and I'm going to trim that and that. And every time it intersects, since it intersects a portion of the model, it creates that like a construction line. So I'm going to create that and that. So now we have our 16. I'm going to hit the escape key to cancel the trim feature. So now we have our sketch. So once again, I'm going to come up, I'm going to finish sketch. So that's done. Now I'm going to press the home key. Now watch this. I'm going to come over here, and I'm going to turn our component off. So now you see our original sketch, and this is how the other sketch is in a higher plane. It's Z plus 0.85 inches above the original sketch because I chose the plane on top of the model. So now when you do that, now when you're building a model, depending on the shape, is I could actually do a sketch and build a different make an addition to the model on top of that. But that's more advanced stuff. That's like I said, that's for another video. But I just wanted to show you on how the second sketch was on an offset plane to the original one. So now we're going to show you how we can use this sketch. So we're going to turn the component back on. We're going to turn the first sketch off just because we can. So, and now we're going to do the hotkey E again, or the extrude as you see up here, and we're going to now we're going to select different parts of that sketch. We don't have to select this middle one, but I'm doing it just because I can. So now that you see it highlighted, now it says new body, and if we take this arrow, draw it up, it'll create that rectangle exactly how we placed it. But that's not what we're doing. So instead, we're going to take this arrow, go down, and it's going to turn red. And see how it turned red? Red is cut. As you see over here on the right, the operation, it'll actually cut your model. So that's how we're making the 16th of an inch gap in the model that we're doing. So now we're going to click OK, and voila, our model is complete. We have the split in it. So once again, we can clamp this into the plasma table, and it'll actually pinch on that Sharpie, so it'll keep it nice and tight so it can't come loose. So I'm pretty happy with that. So all right, so now that we have our model, now we need to save this. And how you save your files is up to you. I do all my designs with a number. So this is number 145. And I do different things with the number in my category and my classifications. If you'd like to learn more like this, let me know in the comments. I'll be more than happy to do a video and explain on how I organize all my files, whether they're through 3D prints or for cutting out on plasma table, laser cut. Pretty neat stuff. Well, I think it's pretty neat. So, but anyways, let's stay on task right here, and let me stop this yakking. So there's our completed model. So now we have to convert this 3D model into a mesh, and basically, and all that is just, it saves it as a three-dimensional object, so we can convert it to something that the 3D printer can understand. So what we're going to do is we're going to come up here to Utilities, click on Utilities. You come down here and it says Make 3D Print. You click that. Now you're selected to highlight, so we're going to select the model we want, which is this one right here. It turns blue so that we know we're selected. Now the output, and once again, there's many different ways you can do this. This is what I found. This works for me, and if you find another way that works, that's going to work for you. That's fine too. There's no wrong way as long as you print the part that you need. So now I'm going to unclick to send to 3D print utility, and this is going to say, like I said, this will save it as a three-dimensional object or an STL file. So we're going to click OK. So we're going to come up here. It says body 1. We're going to change that. I'm going to put my design number, and like I said the design number is because if I find the file anywhere in the computer and it has a number like this, I can look up in my archives in CAD in Fusion 360 and I can see exactly what that file is. So that's the STL file and is saving to the folder that I want. I have different folders for different tasks. So I'm going to I'm going to click save. So that has now saved that as an STL file. So I'm going to close this window down. Whoops, let me just bring that back for a second. So now that we saved it as an STL file, now we have to convert it to a file that the 3D printer can understand. And they understand a G code. And G code is a whole language in itself. And I'm going to leave that topic to somebody who's a lot smarter than I am. But anyways, but we have to convert this into a G code. And basically what it is, we're going to be using what's called is a slicer program. I'm going to show you more detail on this when I get into it. But if you think about it, is if each layer that the 3D printer prints is about 1/8,000 of an inch. So basically it's going to slice every bit of this into like think about slicing a cake horizontally, and you're going to have each layer is 1/8,000 of an inch thick, and you're going to do that all the way to the top. So then it can match the contours of everything. So but that's what we're going to get ready to do. We're going to use what's called a slicer program. And there's a lot of cool stuff you can do with this, but we're going to keep this simple. We're going to use the factory for my 3D printer, voxel maker. I'm going to go ahead and open this program. And not yet. So, and I apologize if I have any display issues, because unfortunately I have a gigantic 34-inch screen monitor here in the office, and I have to size it down just so I can get video friendly images on it. So anyway, so this is the slicer program. There's many out there. This is very simple. This is designed for the one I'm using. The G code you can make is generally work on most all of them. But if you want to do some advanced features, if you want to know about it, like doing the switch panels, then like I said, I have to use a different program, but that's going to be for another video. So now we're going to go ahead and load. So this is already set up for the file. This is just the folder that I always use. I actually have a specific work path that my files go through when I do all this. So there's the 145. So I know that's what we just designed. So I'm going to click that, click open, and there you go. There's our part sitting sitting in the middle of this. And this right here is simulating our build plate, and this is where it's going to be 3D printed. But yeah, I'm getting tongue-tied. Believe it or not, I'm actually still having a whole lot of fun doing this. So anyways, so the part is simulated. The part is on our build plate. You can move it around, rotate it. There's no need to do any of that on this one because it's right where we want it. If it was laying on its side, we could rotate it. We can move it. If you wanted to print 3 or 4 of these things, we can multiply them and you can print 3 or 4 at a time. But we're going to keep this nice and simple. So now that it's there, we're going to go to the print function. We're going to click print. Do this solid, just because we're going to put a little bit of clamping force on it. So I just don't want, especially going to be sitting out in the garage and all the heat, I don't want it to distort or anything. So we're going to print it solid so we don't have any issues. So but the honeycomb is, for most run-of-the-mill stuff, it works great. So once again, we're going to go 145. I'm not going to do a 0.1 on it because it's going to be the original design, and then I always throw a G on the end. Like I said, that's just so I know that it's G code is printer ready and easy to pick out amongst a list of other ones. Now we're going to look up here. Now instead of being a 39-minute print time, we have 1 hour and 8 minutes. It's going to use over 4 meters of filament. So like I said, that's the longer time and more material just because it's solid instead of being honeycombed. So, and that's another thing, that the filament lasts a long time. When it's honeycombed and it's not solid, you can actually save a lot of material. So now you can see when I scroll down through the scroll down through the layers, you don't see the honeycomb anymore because it's going to print it solid, and that's how it's going to look when you print it out. So, but all right, so that's all done. So the G-code file's been made. So hit back, and we're going to close this out. We don't need to save it because we're already done with that. So now that the file's done, is see, here's the files we were working on. That's the STL file, the 145. There's a 145G. That's the file that's G-code ready. It's printer ready, ready to go. So, and I already have inserted in one of my USB drives is I have a SD card. So now this is the original file. So I'm going to copy that, close that out, and then we're going to come over to the SD card, right click, paste, boom. Alright, so now the file's on the SD card. Now we're going to jump off the computer. I'm going to get the camera back out, and I'm going to go set up the 3D printer, and we're going to print this thing. We're going to, all this cartoon stuff we're playing with on the computer, we're going to turn it into a real item. So all right, close this all out, and I'll see you at the 3D printer. All right, now we're out at 3D printer. I've already put the SD card into the 3D printer. So now we're going to get ready to start the print. And the filament I decided to use is I'm going to use this fluorescent green filament. I've had this for a while. It came with a printer I bought, and I don't know, I haven't used it for anything, and I figured, you know what, this would be the perfect time to use it, because anytime in any of my future videos, if you see this piece being used on my plasma table with a Sharpie, you know we made it right here. So anyways, I'm not going to bore you. I got to load the filament. I got to level the print surface. And after I do that, I'm going to fire it up. I'm going to start a time lapse, and you can see the process in action. See you in a bit. Alright, I got my filament loaded, got the bed level, got the fluorescent green filament loaded in there for you. And just going to point out, getting ready to start, but just point out that this is a glass build plate. I really like the glass build plates because when you print out, the first layer is dead flat. So that really turns out nice. They do have, my larger one does have a plastic build plate backed by a piece of aluminum. Sometimes they get a little wavy on those things. Like I say, it's just what you got to deal with for being a larger one. So if I can print on the glass build plate, I like to do that. So, but yes, in this white stuff you see here, getting the first layer to adhere is actually very important. So most of the glass build plates, you don't have too much issues, but I still like to put a little bit of Elmer's glue stick on the surface to make sure the first layer sticks. The plastic build plates, you have to use that every time. So just my experience. But we got that done. We're ready to go. So what we're going to do is we're going to come down here, just select print, and then you see right there, that's our file, the 145G. That's G-code ready. She's ready to go. So I'm going to click that, and we're starting. So the printer actually goes to an auto home feature at this point. And it has to heat the nozzle and the bed up to temperature before it can start. So here's some of the information I have. That's your tip temperature, what the temperature is, and what its target temperature is, and same with the bed temperature. So there are some other settings. I won't go into too much more detail. Then it has a progress bar for how long it takes, but we know this is going to take about an hour. So tell you what, I'm going to stop my yakking, and I'm going to set the time lapse up so you can see this print. Alright, I got to apologize that I lost the
Lost the time lapse. My battery went dead in my GoPro, so I'm kind of working on borrowed time right now. See if glue did its trick. It was a little tight coming off, but this part looks good. Let's see how this fits. Wow, that looks perfect. I think this is going to work great. There's only one thing left to do. We need to go try it. Alright, we're now out in the shop, and we're going to see how this fits. That looks like that fits great. All I got to do is tighten those Allen screws up, and it should be good to go. And since I'm out here, I'll show you, when I talk about the limit is the imagination, here's the tools I showed you earlier. This is a setup I made for this plasma table. I made this mount. These are some alignment tools I 3D printed, which this helps me line the workpiece up. And as I showed you inside, here's my lighted aligning tool, and here's the other one. And I even have a little spot. I keep my Allen wrench I need just for when I change the plasma torch. So once again, that's why the 3D printers are a very invaluable tool, and you can do some really cool stuff with them.
I want to apologize for the long video. I had a lot of information I really wanted to pass along to you, and I hope my enthusiasm really shows on this topic, just because I've really enjoyed 3D printing. But thank you for sticking around this far in the video, sticking around to the end. So if you like the video, please like, share it with your friends, and I'll see you on the next one.